X is the probability of. Finally, we will import our machine learning libraries to build. It's now time to get back to the hands-on session after understanding the basics and theory behind it. We will build a weather prediction model using the Naive Bayes algorithm. You can code along with me by downloading the dataset mentioned in the Colab notebook. Are you excited to implement this Gaussian Naive Bayes algorithm? So let's begin. As always, our first step is to import the necessary libraries we require to build this model. So, first we will import the libraries required for computations, which are NumPy and Pandas, the libraries required for visualization, which are Matplotlib and Seaborn. Finally, we will import our machine learning libraries to build our model. First, let's import train_test_split, then Gaussian NB, and finally other methods required for the performance analysis and accuracy are imported. After importing the libraries and methods required for building our model, we move on to reading the data from our dataset. We will read the data from the dataset by using the pandas read_CSV method. After reading the data, we can display the top 5 rows of the dataset to view the details and attributes of our dataset. After that, if we just want to know the number of rows and columns in the dataset, we will do so by using the shape method. Here, we can see that the shape is 1461 rows and 6 columns. Then, we will use the describe method for calculating some statistical data like percentile, mean, and standard deviation of the numerical values of the series or data frame. Next, we will check if there are null values or missing values in the dataset. This can be done using the methods isNull and any. Through the results, we can see that none of the values are null in any of our columns, as the Boolean value is false for all. We can observe that there are total 6 columns in our dataset: date, precipitation, temp_max, temp_min, wind, and weather. To train our model, we do not require a date parameter. So we create a feature matrix capital X containing the features precipitation, temp_max, temp_min, wind, and a panda series Y containing the parameter which we want to predict the weather. Now, after finishing up the pre-processing of the data, we will view the first 5 rows of the data again to look at the attributes using the head method. Well, finally, we have completed the pre-processing stages and we are ready to build our model on our data. We have removed the unnecessary data too. It's now time to split the dataset into 2 parts for training and testing purposes. So, we will give 70% of our data to our model for training and we will use the remaining 30% for testing on new data. This can be done using the train_test_split method. We will define 4 variables: x_train, x_test, y_train, y_test. We will stratify y and set the random state as 0. The random state parameter is used for initializing the internal random number generator, which will decide the splitting of data into train and test indices in our case. Moving further, after splitting our data into training and test set, we will display the number of rows and columns in all 4 variables. We can see the results are 1022,4, 1022, 439,4 and 439 for x_train, x_test, y_train and y_test respectively. Finally, we move on to build our Gaussian Naive Bayes model using the Gaussian NB method that we have imported. Then we will fit the training data using fit method. Our next step is to make predictions on our test data. So we will use the model.predict method to make the predictions. We have successfully created the model. Now we need to know how efficient our model is for making the predictions. So we will calculate the accuracy of our model using accuracy_score. The accuracy score for both training and test datasets will be displayed. Finally, we create a confusion matrix, which is very popular measure used while solving classification problems. It is a performance measurement where output can be 2 or more classes. It is a table with 4 different combinations of predicted and actual values. The confusion matrix can be made using the inbuilt method confusion_matrix from sklearn. Finally, using the display method, we will display the plot of our confusion matrix. And congratulations, your weather prediction model is completely ready. You can go ahead buy different datasets of your choice and create your own models using the algorithms we have studied so far. I hope you are loving our journey sailing through the ocean of computer vision. That's all for this session. See you in the next one. Till then, keep learning. Thank you.